All right, welcome to Module 4, Lesson 6. Today you're going to be simplifying complex equations to either find a solution or to determine that there's no solution to this problem, okay? You'll know you're successful when you can use properties like the distributive property, the commutative and associative properties, as well as strategies like combining like terms, using keep, change, opposite, and keep, change, flip to simplify and then solve these equations. We're going to review some skills, go over some examples, complete exercises, close out the lesson, and then you'll do your exit ticket. All right, so before we get started, I just want to go over some skills that are going to be super helpful when solving complex equations. So all of these things are strategies you should use to simplify before you solve, all right? The first one I'm going to go over is the distributive property. So anytime you see parentheses with a number on the outside of those parentheses, you want to go ahead and distribute. It's going to make your life so much simpler as you go about solving. So here's how you do that. You're going to take this outside number and multiply it by both or all, sometimes there's multiple, terms within the parentheses. And you know that a term is just separated by the plus sign. So there's two terms here. All right, so we're going to do 5 times 1/2. 5 times 1/2 is just the same as saying half of 5. So this is 2.5. Or you could write it as a improper fraction is 2 1/2. And then 5 times 12 is 60. And then we're going to keep that plus sign in the middle. And you see that this is simpler. Okay, we went from having 5 numbers and some parentheses to just having 2 numbers and no parentheses. All right, so anytime you see parentheses, please distribute. That is the first step when it comes to solving equations, right? If we think back to PEMDAS, this first step, P, is parentheses, which says basically distribute or multiply. All right, the next one is combining like terms. So anytime you have terms that are similar, you can combine them. So as I'm looking at this right now, I see that there are 7x's, and then there's -2 or -2x's. So I can combine those. If I have 7x's and I take away 2, I now have 5x's left, okay? I also have 3/4 and a -4 or a -4. So I'm going to combine these because they're numbers. So if I am back 4 on a number line, and I'll draw a number line really quickly. Here's 0, and I'm at -4. And I'm going forward 3/4. So I'm not going forward all the way to -3. That would be 1 whole space. I'm only going to go back 3/4 of the space. Okay? And if I'm splitting up my numbers into increments of fourths, I went back 1/4, 2/4, 3/4. That means I need 1 more fourth to get here. So I am going to be back -3 and 1/4, right? Because I'm going to be right here, which is back 3, and then there's 1/4 of a piece left. Okay, so I just combined those like terms. Again, it made this so much shorter, so much simpler than it was to begin with. The next one is changing subtraction to addition. So as you can see in this problem here, I have 5 plus 3 minus 21 minus x. I have a lot of minus signs, and when it comes to that, it is just so much easier to turn them all into plus signs, okay? Once you have plus signs or addition signs, you can arrange your problem however you want. So I'm always going to use a strategy called keep, change, change, or some people call it keep, change, opposite. Basically, you're going to take your terms and you're going to change them. So I want to change the minus sign. So I want to change this minus sign. So that means I'm going to keep this, change, and then do the opposite of whatever comes next. Okay? So now I'm at 5 plus 3 plus -21 minus x. I still want to change my other minus sign. So I want to do change here. So I'm going to do keep, change, opposite. So now my problem becomes 5 plus 3 plus -21 plus -x. And now that I have all these plus signs, I can move it around however I want. So again, this is my strategy here. The last one is changing division to multiplication, and we use a strategy called keep, change, flip. So we're going to keep this 17, change this to a multiplication sign, and flip this upside down. When we do that, it's multiplication. We can multiply straight across and solve. Okay, that is so much simpler than it was to begin with. So these strategies I want you to use as you go throughout this lesson today and solve your equations. All right, example 1 says, what value of x would make the linear equation 4x plus 3, parentheses open, 4x plus 7, parentheses closed, equals 4, parentheses open, 7x plus 3, parentheses closed, minus 3, true? And what is the best first step and why? So essentially I need to solve this problem. So I'm going to go ahead and draw my line through my sign. But it's also asking me what's the best first step. And if you think about PEMDAS, parentheses, exponents, multiplication and division, addition and subtraction, you're always going to want to use this as your reference for what's the best step first. So do I have parentheses? Absolutely. So what's the best step? Is getting rid of those parentheses. And I do that by distributing. So that is the first thing that I'm going to do, is I'm going to distribute. So I'm going to take this 3, multiply it by my 4x, and by my 7. And I'm going to take this 4, multiply it by my 7x, and my 3. And everything else in my problem is going to stay the same. So 3 times 4x is 12x's. Keep my plus sign. 3 times 7 is 21. On the side, 4 times 7x is 28x. Keep my plus sign. And 4 times 3 is 12. Everything else in the problem stays the same. Okay, so my first step was to distribute. Now I want to look and see, is there anything I can combine on each side? So I'm looking at my left side first, and I see I can combine these 4x's and these 12x's. And on my right side, I can combine my 12 and my negative 3. So over here, 4x's plus 12x's is 16x's. Over here, 12 take away 3 is 9. And everything else stayed the same. Now that I'm down to a pretty simple problem, I'm going to rearrange this so that I get my x's on one side and my numbers on the other side. All right, so it looks like I'm going to move this 16 to the other side, and I'm doing this way because I know if I do 28 minus 16, I'm not going to get a negative. Okay, over here it cancels, I'm left with 21 equals, if I do the subtraction, 8 take away 6 is 2, 2 minus 1 is 1, I get 12x's, and a plus 9 left. Last thing, not last thing, but the next thing I'm going to do is take this 9 and move it to the other side. I'm trying to get my x by itself. When I do this, it cancels over here, I'm left with 12x's. On the left side, 21, take away 9, I believe it's going to be 12. And I'm down to my last step here, which is to divide, get my variable completely by itself. Right now it's being multiplied by 12, so I will divide by 12. When I do that, 12 divided by 12 is 1. And over here it cancels, and I'm left with x. So x equals 1. That's my final answer. I could check it by plugging it in. And I'm just going to make sure that I answer this question. What was the best first step? Distribute. Why? To get rid of the parentheses. I'm done with example 1. Example 2 says, what value of x would make the following linear equation true? I'm just going to start out like I usually do, draw a line through my sign, and move over here. And I'm looking to see if I have anything I can distribute. I do have parentheses, but as you can see with my parentheses, there's no number on the outside of them. Okay? Now, it might seem like there's no number on the outside of them, but invisible numbers are always around us. So this is actually a -1, and this is actually a -1. Okay? So I can go ahead and distribute first, but if I'm being honest, I'm looking at this problem and there's so many subtraction signs, and negatives, I know that that might confuse me, so I want to go ahead and get rid of as many as I can. Okay, so over here, I'm going to get rid of this one. I'm going to get rid of this one. And I'm going to get rid of this one. Okay. And that's it. On the other side, it's just negative signs. So the first thing I'm going to do is going to do keep, change, opposite. Okay. Here I'm going to do keep, change, opposite. And here I'm going to do keep, change, opposite. Everything else stay the same. All right. Now I'm going to distribute, now that I have those minus signs out of the way, and it clearly shows me that everything has a plus sign. All right, so I'm going to distribute this 1 to both of these, and sorry, it's a -1, and this -1 to both of these. So -1 times 3x is -3x. Keep my plus sign. -1 times -9 is +9. Everything else stayed the same. On the other side, -1 times -11. X is +11x. And -1 times +1 is -1. All right. My next step is going to be to combine some like terms. So on this side, I have a 20, a +9, and a plus -2. On the other side, I don't have anything I can combine. So 20 plus 9 is 29. Plus -2, or take away 2, 28, 27. So 27 plus -3x on this side. And on this side, I have 11x plus -1. So now I'm just going to be moving my terms around so that I have my x's on one side, my numbers on the other. So to do the opposite of this -3x, I'm going to be adding 3x, doing +3x. This cancels. I'm left with 27 equals 11, 12, 13, 14 x's plus -1. I want to get that -1 to the other side, so I'm going to add it. Now I have 28 equals 14x. Divide both sides by 14. Over here it cancels. I'm left with x. Over here, this is not going to be a whole number. 14 won't go into that. Oh no, actually it will, sorry. 14 goes into 28 exactly 2 times. So my answer is 2x. 2 equals x. And my first step was to do keep, change, opposite. Turned my subtraction into addition. I did that to make it a lot easier on myself. All right, example 3, we're going to solve this one now. This one I can see already. There's some fractions and there's some parentheses. And I also have a couple of minus signs, negative signs. So the first thing I'm going to do is I'm going to draw in this invisible one right here. And the second thing I'm going to do is distribute because I have parentheses. All right, 1/2 times 4, or half of 4, is 2x. 1/2 times 6, or half of 6, is 3. Everything else is the same. -1 times 5x is -5x. And -1 times 9 is -9. Next thing I'm going to do is combine my like terms. But I see that I have a minus sign, and I want to get rid of that. So this is the minus sign right here that I want to get rid of. So I'm going to do keep, change, opposite. And everything else stayed the same. From there, I'm going to combine my like terms, so I can combine these over here. And I don't see anything else I can combine. So this becomes 2x plus 3 plus negative 2 is 1 equals negative 5x plus negative 9. Next thing I'm going to do is move my x's to the same side, my numbers to the same side. I'm going to move my 5x's over here. And just to save space, I'm going to just do my same step right there. I'm going to move this 1 over here. Negative 9 and a negative 1 is a negative 10. Okay, last step is to get this x by itself. Over here it cancels. Over here, negative 10 over 7. It's the same as negative 10 divided by 7. You could do that and get a decimal, or you could write this as an improper fraction. I get negative 1 3/7. Okay, we can always check our answer by plugging it back in. And the first thing I did here, first step, was distributed. All right, last example here. Gonna draw a line through my sign. I see parentheses, so I'm going to go ahead and distribute. 2 times x is 2x, 2 times 1 is 2. Everything else stays the same. Okay. The next thing I'm gonna do is see if I can combine anything, and it doesn't look like that I can. So I'm just gonna move right along. I'm gonna try to get my x's on one side, my numbers on the other side. So I'm just gonna move this 2x to this side. And you'll notice something very interesting here. The x's completely cancel out. So all I'm left with is this. 2 equals negative 3. Now, does 2 equal negative 3? Absolutely not. 2 does never, it's never going to equal negative 3. So what does this mean for us? This means that there's no solution. Okay? In math, when you're solving equations, if you ever get something that does not make sense, like 2 equals negative 3, there's no solution to this question, okay? Nothing's ever going to work. The math is never going to check out. All right? So we've noticed before we can get one solution. Now you've learned what no solution looks like. You might see some of these today in your work. All right, for your classwork today, you're going to be doing 6 exercises. 5 of them are just basically solving like we were before. The 6th one wants you to create your own equations that have no solution. So like that one I just showed you where 2 equaled negative 3 and that didn't make sense. I want you to write 3 equations where that kind of comes out as the answer. Something equaling something that's not true. Okay? Pause this video right now, go do these, and then come back and check your work. All right, you should have done this on your own already, and you should be coming back here to check your work. The first thing I'm going to do in this equation is change some of my minus signs to plus signs. So I have one right here, so this becomes keep, change, opposite, this becomes a negative 5. This one is right before my 9, so this becomes keep, change, opposite, becomes a negative 9. Right here there is an invisible 1, and that looks like I'm good there. So the second thing I'm going to do is distribute. I have 2 places to distribute here. Negative 5 times 2 is negative 10x. Sorry, 2x. And negative 5 times negative 9 is positive 45. Over here, negative 1 times negative 6x is positive 6x. And negative 1 times 10 is negative 10. Everything else stays the same. Next step is to combine my like terms. I have a 17 and a 45 over here, and then I have a negative 10 and a positive 4. So 45 plus 17, 55, 62. And over here, negative 10 and positive 4 is negative 6. Everything else stayed the same. Next thing I'm going to do is move my terms around so that my variables are with my variables, my constants are with my constants. I'm going to add 10x over here. Get rid of that negative sign for my x's. This becomes 16x. And I'm just going to do this in the same part. I'm also going to add the 6. So it goes to this side. 62 plus 6 68. Last step is to get my x by itself, so I'm going to divide by 16. Over here it cancels, I'm left with x equals 68 divided by 16. Let me do it on my calculator really quickly. 4.25 is what I got. Okay. That's my answer here. All right, number 2. I'm going to go through here. I'm going to put a 1 there. I'm going to change this subtraction to addition. And from there, I'm going to begin solving. So the first thing I want to do is draw a line through my sign and distribute. Negative 1 times x is negative 1x. Negative 1 times negative 7 is positive 7. 2 times x is 2x. 2 times 9 is 18. All right. Next thing I want to do is see if I can combine some terms. And it looks like I can. I have a 7 and I have a 5/3 here. So I'm going to combine those. 7 plus 5/3 is 7 and 5/3. However, if you look at that number 5/3, this is improper. So what does this 5/3 actually equal? This actually equals 1 2/3. So I'm going to add that instead, so that it's not just like as crazy messy. So 7 plus 1 is 8. And we have those 2/3 left over. Okay? Everything else stayed the same. Next thing I'm going to do is move this 1x over. So it's on the same side as my other x. I have 8 2/3. 2x plus 1x is 3x's plus 18. All right, next I'm going to move my 18 over. And this is where it might get a little tricky. So I have 8 2/3 take away 18. I'm going to take that 2/3 and I'm going to turn it into a decimal. So 8 2/3, if you do 2 divided by 3 in your calculator, you get 0.66 repeating. So this is the same as saying 8.66 repeating. So I'm going to actually do this decimal, take away 18, instead of the fraction, because I don't want to do fractions in numbers. I just want to, decimals are easy. So I have 8.66 repeating minus 18, and I'm doing that on my calculator, just so I don't mess up. I get negative 9.34, okay? I'm trying to get this x by itself, so I divide by 3, I get x equals negative 3.1133 repeating. And that's my answer for number 2. All right, here we go with number 3. I'm going to first take away some of these subtraction signs. I see one right here, so I'm going to keep, change, opposite. I see one right here. It's actually an invisible one, so keep, change, opposite, keep, change, opposite. And now I'm good to go. I'm going to draw a line through my sign and get ready to solve. Now, first thing I'm going to do is just my distributing. Sorry, my arrows look weird. Okay, 4 times x is 4x. Keep the plus sign. 4 times negative 1 is negative 4. Over here, negative 1 times x is negative 1x. Keep my plus sign. Negative 1 times negative 7 is positive 7x. Okay, everything else stayed the same. All right, the next thing I want to do is, I'm looking at this, and usually I would say combine my like terms, but I want to get these fractions away. And what's cool about these fractions is that they have the same denominator. They're both being divided by 9. So to get this denominator of 9 away, I just have to multiply the entire thing by 9. So again, right now it's being divided by 9, so I'm just going to multiply the whole thing by 9 and use the distributive property to do this. When I do this, it's going to cancel out these fractions. So 9 times 4 9s, the 9s cancel out. we're just left with 4. 9 times 4x, 36x. 9 times negative 4, negative 36. And I have plus signs in between all those. So that looks a lot simpler to me than having that fraction. All right, I'm going to do the same thing over here. 9 times 28 over 9 is the same as 28. Okay, the 9 just cancels. 9 times negative 1x is negative 9x. 9 times 7x is 63x. And 9 times 1 is 9. And all these had plus signs in between as well. All right, now I'm going to combine my like terms. So on this side I have a 4 and a negative 36. On this side I have a 28 and a 9. I also have a negative 9x and a 63x. So I'm going to combine all of these things. 4 and negative 36 is negative 32. Okay, keep my plus 36x. On the other side, 28 and 9 is going to be 37. And negative 9x and 63x is going to be 54x's. And keep our plus sign. Okay, now I'm going to move my x's to the same side. I'm going to take away 36x's from over here and do the same over here. I get 18x's. Now I'm going to move my 37 over. And negative 32 minus 37 is the same as saying plus negative 37. So this becomes negative 69 equals 18x. Last step is to get x by itself, divide by 18. I'm going to do this in my calculator really quickly. 69 divided by 18. And I get 3.83 repeating. All right, exercise number 4. Start by drawing a line through my sign and changing my minus signs to plus signs. There's only a couple of them. And the first thing I'm going to do is distribute. Parentheses, right? 5 times 3x is 15x. Keep my plus sign. 5 times 4 is 20. Keep everything else over here. Negative 3 times negative 2 is positive 6x. Negative 3 times 11 is negative 33. Now I will combine my like terms. I have 15x's and negative 2x's over here. I have 7x's and 6x's over here. So 15, 14. 13x's are left over here. On this side, 7x's plus 6x's is 13x's. And I have plus negative 33. Right, next thing I'm going to do is move my terms around so that I have my x's on one side, my constants on the other side. I'm going to subtract 13x from both sides. And you'll notice that something interesting happens. They both cancel and I'm left with 20 equals negative 33. Now, this is not true, so there is no solution. All right, I'm going to draw my line through my sign and change all my minus signs to plus negatives, plus negative, plus negative. From there, I'm going to distribute. Negative 1 times 3x is negative 3x. Keep my plus sign. Negative 1 times 5 is negative 5. Everything else over here stays the same. On the right side, 1/2 times 8 is the same as saying half of 8, which is 4x's. Keep my plus sign. Half of 20 is 10. And everything else stay the same. From there, I'm going to combine like terms. I have 7x's, negative 3x's. I have negative 5 and negative 8 that can be combined. 4x's and 7x's, and then on this side I have 10 and 5. And all these are being added, right? I already took all my subtraction signs away, so These things are just being added. 7x's, oh, wrong thing. 7x's and negative 3x's leaves us with 4x's. Negative 5 and a negative 8 is negative 13. On this side, 4x's and 7x's is 11x's. And 10 plus 5 is 15. All right. Now I'm going to move my x's, my 4x's over here. All my x's on one side, all my constant terms on the other. 11 take away 4, 11, 10, 9, 8, 7x's. And then I'm going to move my 15 to the other side. Negative 13 minus 15 is the same as saying negative 13 plus negative 15. And this is negative 28. Last step is to divide by 7. I get x equals negative 4. All right, last thing here is to write 3 equations that have no solution. So you want it to be something that does not equal. I'm going to start off by doing making sure that my x's are the same. So I'm going to have 2 x's over here and 2 x's over here. That way, when I subtract them, they're going to cancel. And then I'll just have something like plus 5 and then plus 2. So if I were to solve this, it wouldn't work out because I'd do minus 2x, they'd cancel, and I'd be left with 5 equals 2, which it doesn't. So you're just going to make 3 equations like that, okay? All right, to quickly recap this lesson, there's a bunch of things we can do to make our problems simpler as we go to solve them. You can use the distributive property to get rid of parentheses and to expand your problem a little bit. You can combine like terms to make it shorter or have less terms. You can use keep change opposite to get rid of subtraction signs and keep change flip to get rid of division signs. One other thing that I want to note that's super important about this lesson is that today you learned that sometimes problems have no solution, right? So if you get to the end of a problem and it says something like 5 equals 11, we know that's not true. So that would be a no solution problem. Okay, keep that in mind as you go to your exit ticket. All right, your exit ticket for today is only 2 questions. Please go slow with them, take your time, think through them, think about the strategies I shared with you throughout this lesson. And then you're just gonna solve these, okay? Let us know what value for x makes the equation true. I should see all of your work. If it's easier for you to do it on a piece of paper and then upload that picture of the piece of paper, then do that. Otherwise, make sure that it's legible and that I can understand clearly what your answer is.